52, very good. So let me copy it. So 52, the integral from 0 to 2 from the absolute value of 2x minus 1 dx. So that's why a long time ago I tortured you with this absolute value. So remember, the absolute value of an expression is the positive expression if the expression is greater than or equal to 0, is the opposite of the expression if the expression is less than 0. All I have to do is just mimic this for the absolute value of 2x minus 1. So can anyone dictate this? What do we need to write?
In the top portion of the bracket, it's going to be 2x minus 1 when...
So all these are equal. All these have to be the same, right? So 2x minus 1 greater than 0 means x greater than or equal to 1/2. And this one is the opposite, right? So I distribute negative 1. Negative 2x plus 1. I don't have to ever solve this. If this is greater than or equal to 1/2, this must be less than 1/2. So therefore, the integral changes into two integrals because we are looking at a piecewise defined function. And this is one of the properties of the definite integral. Can anyone give us the limits of integration? And which function goes where?
So would the first one be x, so 0?
Excellent.
1/2?
Yes. From negative 2x plus 1. Great job. Yes.
And the second one is 1/2 to 2?
That's it. From 2x minus 1. Great job. Thank you, Gabriel. So I have to now to piece of cake, right? This is not a big deal to determine this these integrals. Any questions on the setup? Any questions on the setup? Okay, so let's calculate then. So negative 2x squared over 2 plus x from 0 to 1/2 plus 2x squared over 2 minus x from 1/2 to 2. Okay then, stay here. So these are gone. So I plug in 1/2, negative 1/4 plus 1/2 minus when I plug in 0, it's all 0. Plus when I plug in 2, 4 minus 2, but careful, minus when I plug in 1/2. 1/4 minus 1/2. Safe to put minus in parentheses, not to forget to distribute. So negative 1/4 plus 1/2 will be 1/4. 25, negative 25 cents subtracted from 50 cents, right? So plus 2 minus, again here, 1/4 minus 1/2 will be negative 1/4 with minus in front plus 1/4. This is 50, right? So it's 1/2 plus 2, so this is 5/2. Okay. Okay, this caught my eye. Are you okay with 51? I'm just curious now what that will lead.
Let's do it if we have the time.
Okay, let's do 51. So the integral from 0 to 1 over the square root of 3 from t squared minus 2 over t to the 4th minus 1 dt. Okay. Okay, so let's take this function aside and see what happens. So the numerator is factorable into t plus 1, t minus 1. The denominator is in t squared plus 1, t plus 1, and t minus 1. There's nothing to it. So this is basically 1 over t squared plus 1. Good. So what is the antiderivative of this? I thought it was much more interesting for some reason.
Or tan of t.
Very good. From 0 to 1 over the square root of 3. We plug in 1 over the square root of 3. Or the same thing with the square root of 3 over 3. Minus when I plug in 0. But our tangent 0 is 0. So which angle has tangent the square root of 3 over 3? And remember, I always tell my students, do not memorize our tangent. It's either 1 over 2 over the square root of 3 over 2, pi over 6, sine pi over 6 over cosine pi over 6, or is the other way around. Sine pi over 3 over cosine pi over 3. And of course it's not this, because this answer is the square root of 3. It's not 1 over the square root of 3, so it must be this. So there is no need to memorize anything other than sine, cosine. Okay. Any questions? Any questions? Okay, I just want to talk about the last thing in section 5.4. So I think I'm on 14. It's called the Net Change Theorem. You remember a long time ago when we looked at that particle that was going the positive direction and then in the negative direction and then coming back, and we were asked to determine the total distance, and we used the absolute value between this point and this point, and then between this point and this point and this point, right? So we said the total distance was the absolute value of going this way, the absolute value of going this way, plus the absolute value of going this way. Well, we have a way of determining the total distance now. We didn't know at that time. So total distance is the integral from time 1 till time 2 from the absolute value of the velocity dt. Yes, that's one of the reasons why I insisted to look at an absolute value to refresh our memory on the absolute value, because this is what we need to do when we're asked to find the total distance. I'm going to share my screen again. So let's see, where are my problems with the total distance? Here they are. Here they are. Okay. The acceleration function. So the velocity, find the velocity at time. So the acceleration function is given to us. Find the velocity at time t and the distance traveled during the given time interval. So please choose. Okay, I'll choose 71, so a of t equals t plus 4. We are given that v of 0 is 5. We are given that the interval is between 0 and 10. Okay? Okay. So we're given the acceleration function. In part A, they want us to find v of t. How do I determine v of t? Anyone?
It's the integral of the acceleration function.
Very good. A of t dt, the indefinite integral. So this is t plus 4 dt, which we know is t squared over 2 plus 4t plus a constant c. This is super important. V of 0 is 5, 0, 0, so then obviously c is 5. So this is t squared over 2 plus 4t plus 5. Now the second half, part B, we're asked to find the total distance, which is the integral from 0 to 10, from the absolute value of the velocity function, t squared plus 8t plus 10 divided by 2 dt. Okay. So we know that the absolute value, we use this in the epsilon delta definition, the absolute value of A over B is the absolute value of A over the absolute value of B. So I will have the absolute value of 2, which will go in front as 1/2, and the integral from 0 to 10 from the absolute value of t squared plus at plus 10 dt. Now I have to discuss the absolute value and see the two options, split the integral, see where it splits. I have no idea because it's not factorable. So t squared plus 8t plus 10 is t squared plus 8t plus 10 when t squared plus 8t plus 10 is positive, or negative t squared minus 8t minus 10. It would be nice if everything would be between 0 and 10 and we only have one integral. We'll see in a moment. T squared plus 8t plus 10 less than 0. So first I have to find the x-intercept. So I have to determine this. Okay, so t equals negative b plus or minus b squared minus 4ac over 2a. So I just want to see what I get approximately, and if those numbers are any of them between 0 and 10. So negative 8 plus the square root 64 minus, that's 24, close, and divide by 2. That's negative, okay, fine. Let's see the other one. Yeah! Excellent. So, the function between 0 and 10 will always be positive. So we can, so the intercept, so the function has a minimum and it crosses at -1 and -1 and -6, so it looks like this. So I don't have to do anything. Yay! I don't have to split the interval. Awesome. That's great news. So then the total distance is the integral from 0 to 10 from, because this is never negative on the interval 0 to 10. So, nice. Lucky me. So this is t to the third over 3 plus 8t squared over 2 plus 10t from 0 to 10. So 1,000 divided by 3, and this is 400 and plus 100. So 1,000 divided by 3, and this is 500. 15, so 2,500 over 3. Luckily I did not have to